developer for integrating map graph technology with the modeling application to accelerate electronic warfare using GPU graph capabilities. So in this role, he exposed the graph capabilities on the GPU by JNI interface to enable the integration without the application developer writing in CUDA C++ or non-Java. So let's welcome James.
Yeah, I'm James Lewis with Systap LLC, and I'm presenting on using MVAPICH-GDR for multi-GPU data parallel graph analytics. And overview, I'm first going to cover previous results, which we actually presented at MG 2014. The last year we haven't really been doing much work on our cluster implementation. We've been focusing on our single node and integration with Java.
Can you make the volume?
How's that?
Yeah.
Okay. So, as I was saying, we haven't done much work on our cluster implementation. We've been focusing on other things. So most of the results I have are the same as last year. So I'm going to go over those pretty quickly. If anyone thinks I'm going too fast and wants me to slow down, just let me know and I'll slow down. Then I'm going to talk about some recent issues we've had with our upgrading the current CUDA driver and runtime along with an MVAPICH version. We managed to have our performance cut in half, and we've not been able to figure out why. And then we also have access to a single node system with 8 KV GPUs, and we were hoping to get better performance than on the cluster because the communication with the all local and was actually much worse than on the cluster. And then I'm going to talk some more about our future plans at Systap. But now I'm going to continue into these are the slides that was Harish Dasari presented here last year. And you see this work done by Harish Dasari, Martin Bearson, Shizong Fu, and Brian Thompson. So, breadth first search is graph search algorithm to find how far away in steps a node in a graph is from a given starting point. And the reason that we chose this, and it's also used as a benchmark, is because it has almost no computation involved. It's all data access. So it's a good benchmark for data-intensive applications that don't have a lot of compute. So it's used in social media, graphs, supply chains, and all kinds of things. I actually talked about that on the wrong slide. So, yeah, the reasons behind why GPUs, I think we've heard several times today. They have high performance, they have good energy efficiency, they're cheaper per block. So, you see related work. There's scalable GPU graph traversal by Merrill. is the first work-efficient BFS implementation on GPUs, and it had very good performance. And then this map graph is our single GPU code, which is actually what went into the cluster BFS was map graph. And this breaking the speed and scalability barriers presented by IBM. They use an idea that we also use in map graph, which is the 2D partitioning of nodes in the graph. So, as I was saying, we use the Graph 500 generator to generate scale-free R map graphs. And then we do a 2D partitioning of directed edges of the square layer. This is really just taking, dividing up the edges in the graph by the source and destination vertices, picking consecutive ranges of the vertex IDs and taking a grid. Right. So on each GPU, we keep one of the partitions of the overall graph. And then we use bitmaps to represent the frontiers. The frontier is the set vertices which are being visited in the current iteration. And we use that, or we communicate that at least as a bitmap, where we just have single bits, and we have a bit for every vertex in the graph. Yeah, so each GPU takes its section of the input frontier and does BFS on its local partition. And then the partitions in each column, if we're looking at the matrix here, they share a section of the vertex IDs for their out vertices, which means that we need to take the partial frontier from both of the partitions in the column and merge them together to get the global section of the frontier. So our communication pattern works by doing a tree-based propagation across the column and then broadcast back across the row. These experiments were done on a cluster at the Ski Institute at the University of Utah. It's a 32-node cluster with 64 NVIDIA K20s. Each with 2 InfiniBand adapters, used CUDA 5.5, used the GPU direct support in MVAPICH-GDR. And these are our strong scaling results. Is keeping the problem size, the number of edges in the graph constant while we raise the number of processors to a pretty, not sure, sorry, that was the wrong button. This is, pretty self-explanatory. Some of these numbers are actually wrong. I should have paid attention. I didn't change the slide. So here's our weak scaling. See, we do not have as good a or no, the strong state, I guess not as good as the weak state. This time. Okay. Okay. Here's our computation, communication, and termination check with the number of GPUs. One of the issues we have for scaling is we use the bitmap for the frontier, which means that every step we're communicating exactly the same size message, even if the frontier consists of a very small number of nodes or vertices. So even if only a few vertices are active, we still have to communicate the same amount of data. Which you can see here. Some of these little blips are, you can see a lot of these in the initial iteration. Actually, there's MPI processes which aren't doing anything. There's no computation at all because they don't have any nodes in there. They don't have any vertices in their frontier to process. But you can see our communication cost per iteration is constant across all iterations. And because of the imbalance between iterations ends up being the dominant cost. Okay, so now finished with Marisha's slides, and I'm going to talk about now recent issues we've had. Here is this is running a test on the NVIDIA PSG cluster using 16 K40s, which is 4 GPUs on each node of the infinite bands. And the results that, well, yeah, the results that we had previously at the same time as the other previous results from last year. We were using CUDA 5.5 and MVAPICH-GDR 2.0B, and we were able to achieve 18.740 taps, which, if you don't know, is billions of traversed edges per second. And when we switched to using CUDA 7 and MVAPICH-GDR 2.1 RC2 with the current version of CUDA driver, our performance dropped to 9.13 data taps with the same configuration. So we're only seeing 48% of the previous performance, and I'm still hoping that the guys here will be able to help figure it out. They've been trying.
Could that be the difference between CUDA versions, or did you try with the same CUDA version and two different editors?
Well, I think it could be some configuration issue.
I think it's due to it could very well be due to a driver issue. I know that there was something which I've talked to people at NVIDIA, and they think there's a bug in the driver that we noticed something where our code would not compile under Windows, but the same code compiled on Linux machine without a problem. And then also where one thing was an error compiling or if it was compiled and run against the new CUDA driver with the old runtime, it would produce errors that it didn't with the old driver version. So that may be part of the cause, but I don't know.
PSG clusters useful to file like elevate like that, because that the PSG system in NVIDIA is open to lots of users. It changes weekly.
Yeah, no, I agree.
Could easily be that there's configure online.
That's true. It could be, but these are pretty. I've run on several different hardware configurations on multiple runs over different nodes, but I can get pretty close to the same difference. So anyway, I just kind of bring this up as an issue that we've come across and not. So another issue is we found very disappointing single performance. We had access to a zero scale machine, which if you're not familiar with zero scale, makes this magic, well, I say magic, but it's really a really neat PCI and PLX switch, which allows, they like to take full PCIe 3 with 16x lanes between 8 GPUs for internal communications. All goes through one switch, doesn't hit the CPU at all. So it's supposed to run very nice. We wanted to test by running, we had a single machine with 8K reads for 16 GPUs, and we wanted to test using 16 MPI processes on a single node, see if it was faster, and it ended up being much slower. And when we run on the PSG cluster, we had a 9.13 gigatabs. And previously we did have 18. So the configuration. Interestingly enough, I actually ran some results after I finished these slides with 8 KBs on the PSG cluster on 2 nodes, 2 Hasbro nodes, with 4 KBs each, and actually better results than we had previously on K40s, which is surprising as KBs are actually slightly slower for compute. Anyway, our future plans at Systap, we've been focusing on developing a GPU accelerated graph database. So we're taking the work that's gone into MapGraph and the cluster DFS implementation we've done, and we're working on using those techniques to accelerate Sparkle queries on the GPU to be integrated with our Java-based Lacegraph database platform. We're also looking at doing translation from a Scala DSL for implementing graph algorithms. So we have a DSL which defines operators, including linear algebra operators and some of the gather, apply, scatter type operators, and vertex-centric type paradigm, and putting that in a DSL, and we're working on writing a translation layer which will take that Scala code and generate native GPU code based on it. And what we think we'll be able to provide is this high performance from GPUs without needing to be a GPU expert programmer. So, that's all I have. Anyone has any questions?
Thank you.
Jack, man, just hello. Yeah. So, I had just a couple questions regarding your performance or the setup that you ran on. Do you know, were you guys having a GDR copy installed on the system? Are you familiar?
That I don't know.
So I'm thinking maybe later on we could discuss with you like some setup and maybe some environment variables that are set. Maybe the new installation had some things missing.
It's quite possible. And that I think I know that in the previous configuration, we didn't have to specify anything about the GDR copy module. So if it was there for the previous results,
You would just
we didn't do anything to make it there. So if the PSG cluster folks took that away when it was there, and that would make that kind of difference, then that's a possibility. I think I would actually have to contact the people to manage the cluster to see kind of what it is.
Okay. Yeah, I guess we should have that type of conversation.
Yeah, but we can talk.
So our experience with evaluating zero scale boxes is sometimes they report the wrong say express topology, which may be interfering with optimizations. So you might want to look into that as well.
Yeah, no, I have quite a few theories on why that didn't work out, and there's a lot of things that would have tried, but we only had access to the system for a week. And we ended up keeping it for a week and a half because trying to get everything working.
Yeah, and in this context, I also want to say, I mean, many times we get this kind of feedback. The steps need to be followed are like we have all the micro benchmarks. So anytime you see any issues in installation or configuration, please run the micro benchmarks first. You should see directly whether those numbers are good or not. That should at least isolate the issues, that there are no issues with the driver, configuration, installations. And if those numbers look good, then some interactions might be happening with the application. So we need to analyze this systematically, otherwise it becomes very hard to see if suddenly you lose performance at the application, where it is going, but we'll be happy to work with it. And as they indicate the PSG cluster, a lot of users are there, they continuously try different things, so we may need to have a three-way discussion about with the sysadmin and you and us saying what is happening.
No, I probably didn't mention it clearly enough, but you guys have been a very big help. You've been very responsive. I've
and we have
exchanged a lot of emails with several of the guys on the team. So
and we have accounts also on the PSG cluster, so we can actually install our things and also give you the paths so that you can use it in our installed version compared to the default version and see where it is.
Alright.
Okay, any other questions? Okay, so if not, let's take a break, half an hour break, and then we'll come back to the final session at the
Yeah.